So good evening, learners. Am I audible? And is this screen visible? Please let me know.
Yes, ma'am.
Am I audible? Okay. So screen is visible. Is it moving?
Yes, ma'am.
Okay. So let's begin with our today's live interaction session. This is the first live interaction session. So welcome everyone to the NPTEL course on post-harvest operations and processing of fruits, vegetables, spices, and plantation crop products. So this course is instructed by Professor H.N. Mishra sir, who is a professor in the Department of Agriculture and Food Engineering, IIT Kharagpur. And I am Shikha Sharma. I'm a research scholar in the Department of Chemical Engineering, IIT Guwahati. So So, my major research area, since I am in the Department of Chemical Engineering, but my major in which area I work is basically food science and technology. So, this is basically the week one live interaction session. So, we will have the 12 weeks. So, we will have 12 live interaction sessions. And uh, all these live interaction sessions are basically oriented towards the doubt solving and is basically for helping you to the tutorial. It will be mostly a tutorial kind of lectures. So it will help you to solve your assignments for the respective weeks. And you can ask your doubts if you have gone through the lecture videos, and if you have some doubts regarding that, you can ask that doubts. And yeah, so you can ask your doubts regarding this, whatever we are covering, the questions we will be solving, maybe some kind of numerical questions or sometimes the theoretical questions. So you can ask all these questions also if you have a doubt in all these questions. And so uh, Basically, if this is a I'm also recording, like if you have any problem with the recording, please let me know beforehand, because I'll be recording all these kind of lectures, and I will upload all these lectures at the end of each. After like this session, I will be uploading this lecture to my YouTube channel. You can access your this lectures, recorded lectures, from the link provided. I will provide the link. And uh, if like sometimes in the meeting, if it is like disconnected, maybe due to power supply or due to internet issues, please join with the same link, and also like uh, wait for me to join also. So I don't know about your basically the most of the students, like what is your name, and the what is your basically in which level you are right now in the bachelor's, master's, uh, and maybe the PhD levels. I am not sure. Also, also it. So I will request you to please put your message. Everyone, please put your name and within which level you are currently, and what is your major. Like someone will be maybe from agriculture background here, or maybe food technology, or maybe horticulture. So I would request you to put in the chat box so that I can access and I can uh, understand about you more. I will request, please put your name, in which class you are right now, like that. So she's in, Sakshi is in BSc Agriculture, fourth semester. So right, like this, you can all put your name and in which course you are enrolled right now, so that it will be easy for me to understand you guys. Okay, Soham is in, say, agriculture. Okay. So we have food tech, agriculture, biotechnology students, and mostly of the bachelor's level. And we also have horticulture student here. We have BCom students also. Okay. Chemistry, BSc, nutrition and dietetics. So we have a wide range of students of different, like from agriculture, horticulture to even chemistry. We have all these. Okay. So we have a mixed kind of batch. Okay. Yeah. So chemistry students are also here. Dietetics, nutrition, food, agriculture, and BCom also. Okay, guys. So since we have the wide range of students from the wide background, so uh, we will be whatever we will be discussing in our tutorial classes. What we will be doing, we will start from the basics and we'll then move towards the advanced, so that it will be easy for everyone to understand whatever is going on, whatever is a concept. Okay. Okay. So assignment one deadline is 5th of August. So please, you guys submit your assignment on time, which is the quiz one. And this particular tutorial will going to help you to solve with your assignment also and discuss the concepts which were already discussed by professor. So topics that we will be discussing in today's class is basically the module one. So module one is basically having compositional nutrition and health values of the fruits and vegetables, and it has also it is covering Indian spices and plantation crops. So it module one is basically having the 5 lecture videos, which has lecture one about horticulture situation in India, and then lecture two is about the fruits and vegetables, basically its classification and the whatever are the different composition of the fruits or the vegetables and its market demand, how is it like the raw and the processed vegetables, how what is its consumption pattern, its health benefits, or what are the different nutrition from different nutritional composition it is made up of. And then it is having the textural, microbial, its biochemical and physiochemical characteristics, and about the quality characteristics and the maturity indices. And lecture 3 is the continuation of lecture 2, which is about respiration of the fruits, ripening and senescence. And then it is having basically uh, the transpiration and condensation part also. Then lecture 4 is about Indian spices, classification, its antimicrobial and antioxidant properties, and about its prevention, which is how we can manage the quality of these spices. Then lecture 5th is about the plantation crops, which is mainly the tea, coffee, cocoa, coconut, and cashew. So we'll be solving like the question basis. On the question basis, we will solve. So first question we are discussing, this is the model question I am telling. So like this, we will be solving all the questions. So first is like, which Indian state is the largest producer? Anyone is saying anything? Okay. So which Indian state is the largest producer of raw cashew nuts in terms of annual production? So it is having like 4 answers or the 4 options like Kerala, Maharashtra, Karnataka, and Goa. So in this particular question, answer is Maharashtra, which is B. So why Maharashtra? Because Maharashtra is basically having the largest, if we can see the map, if it's visible in the in your screen. So you can see the Maharashtra is the one which is having around 199.7, around 200 tons of cashew basically it produce. So it is the largest producer in India of the cashew nuts. So cashews basically it belongs to the family of this anacardiae. So Odisha is another, like it is mostly, if we see, it is in the bottom side of the India. So whatever states are there, like Maharashtra, then next is the Andhra Pradesh, Odisha, then Karnataka, then Tamil Nadu, Kerala. So all the most of like is the southern states, they produce basically cashew. So Odisha is basically the largest cultivated area. It is having the largest cultivated area of the cashew. And Kerala, it is having the more of the Indian cashew industries will be there. And in Karnataka, it is the high productivity among all these states. But the product, but here in this question, like we are talking about the production of the cashew, so it is the state Maharashtra. Okay, so let's move to this next question. Which of the following uh, fruits contain the highest amount of vitamin C? Anyone who would like to answer this question? You can even write your answer in the chat box. I'll be opening the chat box also. So which of the fruit is having highest amount of vitamin C? Like orange, lemon, guava, pineapple. Orange, lemon. So many are saying orange, lemon, guava. So we are getting mostly these 3 answers from the audience. Okay, let's see the answer of this question. So guava is the correct answer basically. So correct order is guava is the highest having vitamin C, then orange, and then lemon, and then pineapple. So basically, if we see the USDA data, so it we can see that this is the vitamin C levels, like this much mg of the vitamin C is present in per 100 gram of these fruits. So if we talk about the highest, so highest is acerola cherry. So it is having around 1680 vitamin C, like 1680 mg of the vitamin C per 100 gram of the fruit. This is the highest. After that, amla. If we see, it is also having, like most of the places, like it is written that 600 amla is having 600 mg per 100 of gram of the fruit. But if we change the variety, it can go up to 900 also. Then here it's given orange. So orange is basically having 53.2 mg per 100 gram of the vitamin C. And if we see the lemon, so lemon, if we talk about without peel, just the lemon, so it is having 53 mg of vitamin C per 100 gram of the fruit. And then guava, it is having 2 to 8 mg per 100 gram. And then pineapple, it is having around 47.8 mg per 100 gram. And kiwi fruit, it is having basically 92.7 mg per 100 gram. So from here, we can see that guava is having highest, which is around 230. And then orange. So orange is having 53.2. And orange and lemon is almost having like the same, but it is, we are talking about without peel. So if we will consider peel also, so somewhat amount of the vitamin C may change, but it is the data for lemon is given without peel in USDA, not with peel. So it is 53. And then pineapple, then is the lemon, which is 53. And then after that is the last is the pineapple, which is very low amount of the vitamin C, which is 47.8. Even the kiwi fruit is having more vitamin C compared to orange, lemon, and pineapple. So here answer is guava. So vitamin C is very important for our health, which is we can obtain from the fruits and also from the uh, like the citrus fruits and also from amla, guava. And it basically, if we don't have this like vitamin C proper amount, like will not consume as per the RDA requirement, then there is a disease known as scurvy, which can which is like deficiency disease of vitamin C. So is this question clear? Can we move to the next question? So which of the following statement about nutritional characteristics of vegetables is are correct? So about the green leafy vegetables, they are the good source of calcium and vitamin C. And then most of the vegetables are rich source of proteins and fats. The third statement is about roots and tubers, and it says that it is having high energy because of the starch content, and vegetables, they can contribute to the dietary fiber intake. So we need to tell from these four statements which all are the correct one. Okay, so we get answer A mostly, which is 1, 3, and 4 is the correct. Okay, let's see the solution. So solution is A, which is correct. So all of you guys are correct here. So basically vegetables, if we talk about vegetables, so vegetables are basically classified into several different classes. So vegetables can be like in the form of the fruit, like okra, pepper, like pumpkin. So these are the fruit part of the plant. So we use it as a vegetable. So this and second is the we can use flower part of the plant for the vegetables, like it includes broccoli, cauliflower, and we can also use the leafy part of the crop or a plant, and we can use it as a vegetable. So it includes basically spinach and cabbage. We can use the seed part also for the uh, seed parts also, which we can consider into the basically the vegetables. So it may includes the pea and lentils, corns, etc. This is the stem or the shoot part. It can also be utilized as vegetables, and it includes asparagus, celery, etc. And the part which is in the below the sand or soil, it can also be used as vegetables, like its root part. So beets, carrots, radish, these are the root part, and the bulb part also, which includes garlic and onion, and the tubers, which includes basically the potato. So they can be basically these vegetables. These can be from different part of the plant, and based on which part we are using of the plant as a vegetable, we can classify this as vegetables into several different classes, like fruits, flowers, leaves, bulbs, tubers, roots, stems, and then legumes or the seeds, etc. So coming to our question, if we talk about all these four statements, let's discuss these four statements. So first is green leafy vegetables, basically uh, yeah. So green leafy vegetable is a good source of calcium and vitamin C, and vegetable is a good source of proteins and the fats, and dietary fibers also, high amount of starch content should be there. So let's see the different statements and their justification. So most vegetables, they are basically poor in proteins and the fats, because if we see in the fruits and vegetables, maximum amount is the water content. So if we see different vegetables, like in this table it is given. So if we see asparagus water content, it is around 93, right? So like this, onion, it is around 88. Tomato, around 94% of the water is there. In lettuce, it is around 95% of the water. So in if we see the water content in the vegetables, it's around from maybe 88 or 85 to 94 or 95. So maximum is the water, and rest, if we talk about after water, if we remove water, then the different vegetables, they'll have other nutrients like the proteins, fats, sugars. And if we see this fat, the fat content, if we see it's around, it's very, very less, even it's less than 1%. So fat content in the vegetables is very less. And also if we see the protein content, it is also very less. In some, it can be around 5%, or most of the vegetables, it is also very low. So most of the vegetables, they'll not have proteins and the fats, but they'll have a good amount of the carbohydrates, or we can say one is a starch and another is a dietary fiber. So it is having the good amount of dietary fibers in it. think there was some internet issue. Yeah, so we were discussing that if we talk about the carbohydrate, so if we talk about the carbohydrate, which includes starch and dietary fiber, so basically it is these vegetables, they are good amount, they have good amount of this dietary fibers, both the soluble and insoluble dietary fibers, because they are the plant part. So it will have different kind of cell walls. So it is having in cell wall like different kind of polysaccharides in it. So that will be basically having good amount of the dietary fibers in that, in all these vegetables. Also, these vegetables, they are having good amount of these micronutrients, which includes both vitamins and also the minerals. Like they have good amount of vitamin C, or they have the vitamin B also. In some vegetables, there are vitamin E also, and they have the minerals like calcium, then magnesium, iron. So all these minerals also they can be found in the vegetables, but they can also possess some kind of toxic constituents. Like these are the anti-nutritional factors, so they may be the inhibitors like trypsin inhibitors, like those, and they can be, so vegetables are usually processed before we are cooking them, or what we are cooking them before we are eating. So we can have different like operations like heat treatment, like blanching or other. We basically give high heat treatment so that all these or we wash also so several times, so these toxic constituents can be removed. So vegetables, they have good amount of dietary fibers as we discussed. So these are some of the vegetables which are having very high amount of the dietary fiber. So it may includes like carrot. So carrot is having good amount of the fibers. Then green peas is also having good amount of fibers in them. Broccoli is also having good amount of fibers in them. And cauliflower also, corn also. So these all vegetables, they are having good amount of dietary fibers in them. The green leafy vegetables like the spinach and the coriander and the drumstick, they leave good sources of the, they basically are having, and the drumstick leaves, they are also having like good amount of the calcium, beta carotene. So as we discussed, these vegetables, they are having good amount of uh, minerals and vitamins also. So we can see in basils, it is high in vitamin A and vitamin K. And spinach, if we talk about, it is rich in vitamin C, lutein, zeaxanthin. Then cabbage is rich in vitamin C, vitamin B6, and folate. So like these vegetables are good source of the different vitamins and also the minerals. So next is the roots and the tubers, which includes the category of potato, sweet potato, cassava. So this is cassava, and this is potato, and this is sweet potato. So all these basically having the good amount of starch content in them. In cassava, the starch content is around 27 to 36%. and then potato 13 to 16, and sweet potato it is 18 to 28, and then in yam it is 18 to 25. So from all these discussion, we can say that vegetables they are having good amount of fibers, and but they are not having proteins and the fat much. And in green leafy vegetables, it is having a good source of the calcium and the vitamin C. So it is basically rich in minerals and vitamins. And then roots and tubers, it is having high amount of starch content. So here option A. So statement 1, 3, and 4 are correct here. Next question is about, in column 1, we are having different fruits. Let me check how many students have joined today. If you guys have any doubt, can please unmute yourself and you can ask your doubts. Okay, so we were discussing this question. So in column 1, we have different fruits and the vegetables. So first is dates, second is citrus fruits, third is radish, and fourth is green onion. And in column 2, we have the respiration rates. How much is the respiration rate? Very high, moderate, low, or high? We need to match column 1 with the column 2. Okay, so Sakshi has already given answer that C is the correct answer according to her. Anyone else who want to attempt this question? Yashvi is saying B. Does anyone wants to say anything? Okay, let's see the solution. So here answer is A. So let's understand what is respiration rate first. So respiration is basically, it is a metabolic process in which the cells of the fruit, so this is fruit, so the organic matter like sugar will convert into energy, which is ATP. Yeah, so we were discussing this part here. So respiration is basically, it is a metabolic process where a fruit or it will basically convert matter, which is organic matter like sugars, like in fruits we have glucose. So this fruit cells, what it will do, it will take this glucose and try to convert it into energy, which is ATP. And this process is basically governed by different enzymes. So and it will basically, these enzymes will take oxygen. So these enzymes in this, like in apple, so there will be different enzymes. They will take oxygen, and the oxygen will going to react with the glucose, and the oxidation will, this oxidation reaction will happen, and basically the glycolysis process uh, it will undergo, and then it will take another process, which is TCA, and then which is uh, uh, like after this, it is the electron transport chain. So there are different biochemical pathways will this whole apple will take, or in the apple cells, these biochemical pathways will be there. And after that, it will convert this glucose basically. At the end, it will give the energy, which is in the form of ATP, and remove some of the byproducts, which is like the CO2 and H2O. So this whole process of taking the oxygen, so and converting into the these glucose or the other organic matters, like the uh, any form of the sugars, so it will convert it into energy, which primarily constitutes of the enzymatic oxidation of basically these organic substances in the presence of oxygen. So in the presence of oxygen, these glucose or the organic substances, they will be converted into energy. So this is the respiration process. So in respiration, oxygen is basically taken up. So basically, if the respiration rate is more, that means the shelf life will be lesser. So these respiration, basically it can be mostly the aerobic process, and anaerobic respirations also are there. So the aerobic respiration, it basically consists oxidative breakdown of these organic substances like the carbohydrates, proteins, and the lipids. Whereas in the anaerobic respiration, limited supply of the O2 will be there. So the fermentation kind of the reaction will process, and from glucose, alcohol will produce when oxygen is not there. So the metabolic pathways which will be followed will be glycolysis, TCA cycle, and electron transport chain or electron transport system. So if we undergo from this process, we know that when aerobic respiration is there, the energy production or the ATP production is more as compared to the anaerobic respiration process. So respiration rate is basically the amount of, like, it is basically measured using the, if like suppose this is a container and in which I'm putting some fruits in this container. So this is the head space of the container, which is the empty space. So these fruits or the vegetables, they will take oxygen as we respire, and they will remove or they will produce carbon dioxide. So since the carbon dioxide will be evolved, so its amount will increase with time, and the oxygen which is present in the head space, in the closed head space, this amount of the oxygen will go down. So the change, if the respiration is happening, that means there is a change in the concentration of the gases which are present in the head space, which is mostly the oxygen and the carbon dioxide. So respiration rate produce can be measured using measuring of these gases in the headspace. So it can be measured either in terms of the how much is the oxygen consumed by the fresh produce or how much is the CO2 produced by the any fruit or any fresh produce. So respiration is nothing but it is basically the measure of these headspace gases. That's amount of oxygen consumed or amount of CO2 which is produced by particular weight of the sample in particular time. That is the respiration rate. So if the respiration rate is higher, that means the higher will be the spoilage or higher will be the fruit will go towards ripening and its senescence or decay. So its shelf life will be shorter. So this basically respiration rate, that's why it is very helpful when we are checking the perishability or the shelf life of any food product, especially in the case of fruits and vegetables. So respiration rate is a good indicator of shelf life. Basically determines the post-harvest physiology. So with the respiration rate, we can understand in which stage after the harvesting the fruits or the vegetables in which state it is there. Is it in the ripening state or is it in the senescence state? And periodic measure. So it is basically, it indicates the storage potential of the plant produce. So it is basically the good, this respiration rate is a good indicator of the spoilage or the shelf life of a product. So if we talk about our specific food products, so dates, basically it is having around, we see dates, it is a very low, when we talk about at 20 degrees Celsius, so it is, its respiration is very low, so it is less than 40 mg CO2 is reduced per kg of the dates per hour. So nuts, dates and dried fruits, they have the low respiration activity and are classified under low respiration category fruits. And the citrus fruits, they are the low respiratory respiratory rate reduced. So it is basically having 40 to 80 mg CO2 reduced per kg per hour. Includes tomatoes and the eggplant and the citrus fruits. So it is having around it is having around moderate respiration rate, which is in the 40 to 80 range. Radish belongs to the higher respiratory products. So radish, ripe, avocado, and the figs, they are around 80 to having, they are having 80 to 120 mg CO2 they are produced by the 1 kg of the sample in 1 hour. So green onions, they are having the highest respiratory rate, which is very high, which is greater than 120. So it includes other products like mushrooms, green onions, and strawberries, which is having extremely fast metabolic activity, and they are therefore having high respiratory products, very high respiratory products. So date is having a low respiratory product. And then the citrus fruits, which is moderate. Radish is high and green onion is very high. So answer A is correct here. Next question is that a fruit exporter is preparing a shipment of banana and mango to be sent overseas to ensure they arrive at the destination with optimal eating quality and extended shelf life. The exporter decides to harvest the fruit at the mature green state. He stores them in the controlled condition and plans to apply ethylene treatment just before delivery to initiate the ripening. So this method will work or not, or if it work, why it will work. So basically we have banana and mango, two fruits. So the exporter wants to send them overseas, and he basically is harvesting it at a mature green state and not allowing it to get ripened. So it is saying that after that he is trying to apply ethylene treatment. So will these fruits, banana and mango, they will ripe or not ripe? And if yes, why? Anyone who would like to answer this question? Okay, so Kashish Rana, C. Yes, these fruits will going to ripe because they are respiratory. Would like to answer this question, or are you agreeing to Kashish? Okay, so we got many answers as C. So yes, you guys are correct, I think. So basically, this there are fruits which can be classified into these climateric and non-climateric fruits. So it is based on their respiration rate. So if we talk about the banana and the mangoes, they come into the category of climateric fruits. Whereas if we talk about citrus fruits, grapes, berries, and pineapples, they come into non-climateric fruits. So the climateric and non-climateric fruits, the difference is that in the when there is the time period if we are studying them in the particular time, like after harvesting, if we see them how they uh, mature or how they ripe, so we can see that initially there will be the cell division step in any of the fruit, and then cell will enlarge, and it is the growth stage basically until here. Initially the cell division will be there, and then this is the enlargement. So there will be rapid growth will be there in any fruit. After that the ripening stage comes, and after finally the senescence stage will be there. So this is until ripening, and this is last at the senescence or the decay stage. So in any fruit, these four steps will come, or the growth stages will come. But in the climateric and the non-climateric fruits, they will act differently. So the climateric fruits, they have initially in the cell division step, they will have some respiration rate, and it is the minima it will go, this respiration. And after some time in the maturation step, this respiration rate will enhance. So this respiration will be more, because at the in the when the fruit is already matured, like this is the different steps: the cell division, cell expansion, maturation, and in ripening. here like until here it's like the fruit is developing, and in maturation state, from maturation to ripening, the color is senescence state where the fruit is not good for the consumption. So if we see in the climatic fruit, if we are maturation step, which is the green step, so maturation, which is after produce basically ethylene gas, which is a natural hormone which will going to increase the respiration rate. So ethylene will be there. So because of that, its peaks we can see region, ripening region. So here the fruit will ripen to the like the mango will be from green to yellow. And also if we see here banana, if we are harvesting in the green, and then it will going to convert into yellow, which is a matured, sorry, this one, sixth one, which is matured state, because there is a production of ethylene gas, which will going to, which is a growth hormone, or this is a kind of a like gas which promotes the growth into the climatic fruits. Whereas if we talk about the non-climatic fruits, what they will do, they will have the ethylene, like they will initially uh, the respiration rate will be higher, and it will come to the low minima, and until the end it will be low only, and the ethylene level is also low only. So these kind of non-climatic fruits, they must ripe in the on the plant itself, so that because after harvesting they will not ripe. So the climatic fruits, they basically emit a great amount of ethylene gas as the fruit ripens, and after ripening peaks, their ethylene production drops off by a significant amount. So the banana and mango, they are the climatic fruits, and they can be harvested mature but in the unripe state, so that then later we can give ethylene gas, and because of that the respiration rate can be triggered, and uh, the maturation or the ripening from maturation to ripening can happen. So it is a good strategy for the transportation if we are sending in different market. So this is a good strategy for the climatic fruits, but not for the non-climatic fruits. They will going to after the product has been harvested. They only ripe while it is so mango. If we are harvesting like green, and ethylene gas to, to the ethylene gas, the unripe mango, the cell wall will be intact in the form of the chloroplast, which will be going to convert into chromoplast. So yeah, so we were discussing that in the unripe, then in unripe mangoes, the cell wall is intact in the form of chloroplast, But when we give the treatment of ethylene or after the maturation, the ethylene gas is produced. So it will convert into the ripened state, which is the yellow state where the color change to yellow, and also there will be the cell breakdown will also happen. So that will going to be change in the texture of the food product. So the texture of the mango from green, when it converts to yellow, its texture will also going to be softened, and the more sugar will be produced, so it will taste more sweet, and the cell break will happen. So the chloroplast will be converted into the chromoplast. When the fruit is or the mango is converted from its maturation to ripening. So it's obviously the good strategy to go for. So these fruits, they can undergo respiratory climatic. So ethylene can trigger the ripening even after harvest when it is in the transportation. So it is a good strategy to go for banana and mango, but it is not good for the non-climatic fruits like citrus fruits or the grapes or the berries. Okay, so let's solve this question regarding the respiratory question value for lipids. What is the respiratory RQ value for lipids? So respiratory question value, basically it is the ratio of CO2 production divided by the O2 consumed. So we discussed that when we are having the respiration process, when the fruit is undergoing any respiration process, so what it will do, it will take some O2 and it will produce some CO2. So O2 will be consumed up in this process and CO2 will be reduced. So here is the question which is asking and the ratio of them is respiratory question and respiration question. So here the question is asking what is the RQ for lipids. So it is 0.7 or 1 or 1.3 or 0.9. Okay, so Poonam is saying it's 0.7 and Sakshi is saying A, which is also 0.7. Satyam 0.9. Okay, let's see the answer of this question. So answer is A, which is 0.7. Let's see why. So the RQ value for the lipids is 0.7 because we see the reaction of the carbohydrates of lipid, which is suppose I am here taking steric acid, it basically consumes around 26 moles of the oxygen and then it's 18 moles of the CO2, 18 mole of the H2O and energy. This is the general reaction for the lipid. So RQ is basically, we discussed RQ is how much is the CO2 consumed divided by the oxygen, which is how much is the CO2 produced and how much is consumed. So RQ will be how much is the CO2 which is produced around 18 when lipid is undergoing the oxidation process. This is basically the enzymatic oxidation processes because all the here all the enzymes will be involved in a biological system. And how much is the oxygen consumed in this process? 26. So 18 divided by 26 will be around 0.7. This one, A. So for lipids and proteins, RQ value is generally less than 1. And In carbohydrates, basically RQ value is around 1. So because here this is hexose, so anything like glucose or fructose. So this, when one hexose is uh, uh, converting into energy, so 6 O2 is basically used and 6 CO2 is produced in this process, and 6 H2O and energy is produced. So the equal number of CO2 and O2 uh, moles are there. So RQ will be 6 divided by 6, which is 1. So it is carbohydrates, RQ value will be 1. In organic acids, if we talk about, RQ is even more than 1, which is uh, around 1.3. So here in organic acids, around 3 moles of the oxygen is consumed and 4 moles of the CO2 is produced and 3 moles of the H2O is produced with energy. So if we see here, the ratio will be, RQ will be 4 divided by 3. So it will be greater than 1, 1.3 around. So for organic acid, it is 1.3. And if we talk about the fermentation process, even the RQ value is even greater than 1.3, because there more amount of the CO2 is produced, because there is this glucose is converted into alcohol. Glucose is converted into alcohol. Is the internet connection okay? Okay, so production in the fermentation, what happens is there is a production of basically ethanol.
अगं मधुरा माझं तृप्ती
There
शंकर
is
गायकवाड
production
केलंय.
of ethanol.
तृप्ती शंकर गायकवाड झालंय.
Someone is unmute, I guess. Someone is unmute. Can you please mute yourself if you don't have any doubt? Yeah, so in fermentation process, what happens? Yeah, so in fermentation process, what is happening? Ethanol is produced due to the decarbonation CO2 without uptake of. So there will be more amount of the CO2 is produced and the oxygen is not absent in that particular environment. So oxygen is less or the minimal. So RQ value is even greater than 1.3. So answer A, which is 0.7 for the lipids, is correct here. Next question is, which of the following methods is used to measure the respiration rate of refuse using the air gas type container, which is flow through method, permeable system, closed system, or open system? So there are different methods to measure the rate of the respiration. It involves like the flow through method, permeable methods, closed system, open system. And this question is asking if we are using particular system, like we are using gas tight container, so which system is there?
I'm sorry, guys, for the internet issue. Today it's happening multiple times. I'm so sorry for that. So, so
Ma'am, please can you let us know? Yeah, every session is for 2 hours from 4 to 6 each Sunday. Yes, guys. So you answered correctly. That answer C, which is a closed system method, is correct here. Okay. So basically, we have these systems when we are measuring respiration rate. We can measure from different systems like flow through method. We can measure using permeable method, closed system methods, and open system approaches. So the closed system method, it basically involves the use of a gas tight container of known volume like this. So is the internet okay? Yeah. So in the closed system, when we are measuring respiration rate of any fruits or the vegetable using a closed system approach, so it uses basically the gas tight containers, which is having known volume, which is having known volume like this. There will be containers of usually made up of the materials where the gas can be inherted, like it will not pass gas from this material. So majorly we use glass materials, and also we can use acrylic like the chambers made from acrylic or acrylic. So uh, like this we make the chambers, and in this we put the fruits of known weight. We measure the weight of the fruits and we'll put in particular this chamber which is having known volume. So in the chambers will be basically closed, and then the respiration rate will be measured using the we can this headspace gas. So in this headspace gas, the syringe will be put, and the gas will be taken out from the syringe, and the gas will be analyzed over the time for how much oxygen is there and how much carbon dioxide is produced with the time. We can measure like this. So this is one approach to measure the amount of respiration, how much is the respiration or amount of the O2 and the CO2 in the particular chamber with time. Like when we put, then how much is the respiration, and after maybe 24 hours or 48 hours, how much is the what is the change in the level of the O2 and CO2 will be measured. Like this is a closed system. And another is a flow through system where what happens, uh, the product basically is put like this in the container, which is basically a impermeable container. Like the gases will should like the gases should not transmit from this particular container. And in this, what happens, there will be one inlet will be there for gases. So gases like it will continue flow at a constant rate. So there will be a mixture of gas which will flow at a constant rate from the inlet and will go out from this outlet, gas outlet. So there will be a continuous flow of the gas. So suppose here our fruits are there and the gas is particular amount of the gas or gas concentration will be there, and here this fruits are also producing some amount of the carbon dioxide and consuming some amount of the oxygen. So this gas will take this amount of the carbon dioxide and it will go out, and here will be the sensor which will going to sense how much is the change in the concentration of the gas. So the respiration rate, basically they are calculated from the absolute difference in the gas concentration between the inlet and the outlet when the system reaches steady state. So what will happen? How we know already in the inlet how much is the like the concentration of different gases, like in inlet suppose O2 is X% and CO2 is Y%. And after it goes through this chamber, it will the concentration of O2 and CO2 will going to change, and the sensors will measure. So based on the change, the amount of oxygen and CO2 reduced from the fruits can be calculated. In permeable methods, the fruits will be there in a like known dimension of film, like the plastic film or sometimes the aluminum film, which is having the known permeability. How much O2 this material, this plastic film can pass, or how much CO2, how much CO2 can be passed through this particular plastic film. So we know already this much amount of the transmission, and then the steady state concentration we will measure of O2 and CO2, and based on the mass balance, we can understand how much is the respiration going. So already this fruit is producing some, like this fruit is there, it will take the oxygen and produce carbon dioxide. And we know already the permeation or the transmission through the particular film or particular material. Based on that, we can calculate how much is the respiration of this particular fruit in this permeable system. So in this, basically, here it's closed system because in the gas tight container, we put only in this closed system approach. Next is the respiration rate of carrots is given as this: 8 mg CO2 is produced by per kg of the carrot per hour at temperature 6 degrees Celsius. And when the carrots are kept at 20 degrees Celsius, the respiration rate is increased to 20 mg CO2 production per kg per hour. So what is the temperature quotient? So we know that respiration rate is affected basically with the temperature. If we are changing the temperature, if we are increasing the temperature, the respiration rates increases. And if we are decreasing the temperature, the respiration rate decreases. Same like if we are changing the concentration of oxygen and the CO2, respiration rates change. So when there is change in oxygen level, like less than 10% oxygen is there, so there is a significant drop in the respiration rate. While if there is a less than 2% oxygen, then that means the process or the respiration process is under anaerobic respiration, or the fermentation process is basically occurring more. When the CO2 concentration it is at 20%, then the anaerobic respiration it increases. So based on the level of the gases, the respiration anaerobic or aerobic takes place, and that's why it affects the respiration rate. And due to different stress, like physical stress, like the mechanical injury or the chemicals, we sometimes we inject chemicals, and the biological, which is because of the microbial load, and sometimes because of the water stress or what less amount of the water. So all these stresses, they may also induce, they may also elevate, or they may also suppress the rate of the respiration. So in this question, we need to calculate the temperature question Q10 value here. Anyone who has already calculated, please let me know. Poonam is saying 1.9 is the answer. Okay, let's see. So answer is B, which is around 1.522. So here, basically, this is basically the formula for calculating Q10 or temperature quotient value. So the respiration rate of any biological reaction, it increases with temperature based on this Vent-Off rule. So this is Vent-Off equation. So within the physiological temperature range, the velocity of a biological reaction increases 2 to 3 folds when we are increasing 10 degrees Celsius in the temperature. So when there is a change in 10 degree Celsius of the temperature, the rate of the reaction, it basically either doubles or triples. Please, can you mute yourself? The ratio of the reaction rates, it basically at the two dissimilar temperatures is the known as the temperature quotient. So when at different temperatures, like at low temperature, the reaction rate will be something different, and at high temperature, when we're increasing 10 degrees Celsius of the temperature, there is a change in the rate of the reaction around 2 to 3 times. So when there is a temperature, with the temperature, there is an increase in the respiration rate. So we can term that particular ratio as temperature quotient, and it is basically calculated using this formula, which is Q10 equals to rate of the respiration at temperature 2 divided by rate of the respiration at temperature 1 to the power 10 divided by temperature 2 minus temperature 1. So at low temperature, basically respiration rate is low, so the shelf life is more. But at higher temperature, the respiration rate is more and the spoilage is faster. So let's solve this question. So here Q2 equals to R2 by R1 divide to the power 10 by T2 by T2 minus T1. So if we substitute the value, so at R1 is basically given as 8 mg per kg per hour. R2 is 20. This is at temperature 20 degree Celsius, and this is at 6 degree Celsius. So Q2 equals to R2, which is 20 by 10 upon T2 minus T1. T2 is 20 and T1 is 6. So Q2 is equals to 20 divided by 8 is 2.5, and 10 divided by 20 minus 6 is 14. So 10 by 14. So 2.5 to the power 10 by 14 is 1.92. So Q2 value is 1.92 here. Okay, let's solve this next question on the transpiration. A tomato has a surface area of 150 centimeter square, and it is stored under conditions where the vapor pressure deficit is 800 Pascal. The measured transpiration rate is 0.5 0.018 per determine overall mass transfer coefficient K in kg per meter square per second per Pascal. Please try to solve this question. Anyone who has solved this question? Okay, we are seeing the solution part. So basically, here this question is regarding transpiration. The transpiration is basically a process where there is an evaporation of water from the cell surface to the intercellular spaces and the diffusion of water molecules basically out of the plant tissues or organs into the atmosphere or the surrounding air. So like this is a bell paper. So it is the 0 date reading just after harvest, and after this is the 3 day it looks, and after 7 days at 20 degrees Celsius and 70% RH, this is shriveled. So water is basically lost from its tissues. So the water loss from the fruits and the vegetables basically they are lost from the tissues, and it induces water stress in the tissues, which may enhance or accelerate the decay process or the senescence process in the commodities, and due to the increased rate of cellular membrane disintegration and leakage of the solute. So sometimes when there is a 2 to 5% of the transmission or the water loss is there, so what happens, it is not good or suitable for the market or the economic perspective. So if we talk about transpiration process, how it happens from the plants, so we can see when we are wrapping one polythene over a plant tissues or the leaves, some water are condensated in the form of condensate we can get. Why? Because there is a process of transpiration is going on. So transpiration basically happens from the stem, because there are the different pores in the leaves of the plant, or also on the surface of the any fruit or vegetable. So because of the stomata present there, so this because there will be sometimes opening of this stomata and stomata, and sometimes there will be this closing. So because of that, the water is lost from the tissues of the or the cells of the plants. Okay, let's see this question. So in this question, we were given transpiration rate, and we need to and also the surface area and the water vapor deficit, and we need to calculate the overall mass transfer coefficient. So in the lecture by Professor Mishra sir, so there is a one slide which is having the formula of rate of transpiration, which was TR equals to K into AS into del P. So here K is overall mass transfer coefficient, which we need to calculate. AS is the area, surface area of the product, which is given as 150 centimeter square. So when we convert into meter square, it will be 150 into 10 to the power minus 4 meter square. And del P is the vapor pressure deficit, which is basically how much is the pressure difference. So suppose this is a leaf of the plant. So from the leaf of the plant, when it is having water droplets, the water will go from the leaf of the plant to the surrounding air. So this vapor pressure deficit is VPD. So it is a difference basically between the vapor pressure at the leaf, which is due to the evaporation rate, and minus vapor pressure at the surrounding air. So this del P is basically this pressure deficit. So it is given as 800 Pascal. Then rate of transpiration, it is given as 0.018 kg per second. Now we need to calculate this K, which is overall mass transfer coefficient. So in this formula, we can substitute the values. So TR is given as 0.018, this, and then equals to K, which is unknown, into the transpiration, which is, sorry, which the area AS, this, and into area, which is this, and into del P, which is 800, this value. So 0.018 equals to K into 0.0150 into 800. This equation, if we solve, and so K will be equals to 0.018 divided by this value, 0.015 into 800, which is 12. So 0.018 divided by 12 will be 0.0015 kg per meter square per second per Pascal, which can be written as 1.5 into 10 to the power minus 3. So here answer is D, which is this. Okay, let's solve this question. So the texture and firmness are considered critical maturity indices in evaluating the fruits and vegetable quality. Reason is instruments like penetrometer and texture analyzer are used to measure fruit quality. So we need to tell about the assertion and reason, what we understand, if it's true or not. We know already that the quality characteristics of the fruits and vegetables, so it is basically important for, so that the fruits and vegetables can be acceptable in the market, and we can get the good amount of value from it, and also based on the nutritional value and from the consumer satisfaction, the quality characteristics of the fruits and vegetables should be optimal. So quality characteristics can be the external to the food product or also the internal to the food product. So if we are talking about the external parameters, externals can be included like the color of the fruits, or the size, or the shape, or the basically the how is the surface condition of the fruit. And if we talk about the internal characteristics of the parameters, it includes like what is the nutritional property of the food product, or also its value attributes, which includes like what is the firmness, and what is the flavor of the food product, also what is the taste. This value attribute, it includes basically what is the about the texture of the food product. So here we are talking about the quality characteristics of fruits and vegetables, in that the value attributes, the texture or the firmness basically comes. In the nutritional attributes, mostly like the nutritional profile, like the fats, calories, or protein, or acidity, or soluble solids will include. And in the food safety attributes, mostly the pathogens, the microbial load, they will be there. And in package attributes, the labeling and the packaging related quality attributes will be there. And in production process attributes, mostly the genetic modifications, or it may include like what is the environmental impact, and also it may include the pesticide usage, or the workers safety will be ensured or not. So in this production process, all these will come. Right now we are talking about the specifically the value attributes and the texture in this question. And answer C is correct here, which is that assertion is true, but the reason is false. So basically, the texture, which is basically the measure of hardness, adhesiveness, cohesiveness, and springiness and gumminess. So in texture, all these properties combinedly known as basically textural properties. So the hardness basically of any product is how much is the peak force of the, if we are, suppose this is a fluid, and if we are applying some pressure or the compression, so what is the peak force of the compression cycle is there, which is defined as a hardness. So which is defined as necessary to achieve a required level of deformation. So suppose in any fluid, I am applying some kind of compression or the pressure or some kind of the force I am applying, and this fluid is basically showing some kind of the deformation, then that force is hardness. So it is the final power required to reach a stable deformation. If we talk about in the terms of the graph or the plot, so when we plot, when we are having this fruit or vegetable under the texture analyzer, which is continuously applying the force or the from the above side, so the force applying is taken in the y-axis and the time of the application is on the x-axis. So when we are plotting, we can see some this kind of the behavior. So the force will increase initially and it will increase. So when we are applying force on the particular fluid, so the pressure or the force will increase up to a certain time, and after that the deformation will be there and the force will going down. So this maximum force will be hardness. Then adhesiveness is basically the force required to detach a sample from the probe and is calculated as the field surface of the negative peak. So this is the negative peak. So when this probe is deforming this particular fluid, then there will be some kind of adhesion between this fluid and the probe. So because this is known as adhesion basically. So adhesion is basically the force which is required when we are detaching this probe from the sample. So it is calculated from this negative peak area. Next is the cohesiveness. So cohesiveness is basically calculated as question field surface indicated by the curve of the second and the first press. And then there are other terms like springiness and the gumminess also. So springiness is basically L2 by L1, which is this positive area until this, from this 0 to this peak. What is the area of this peak divided by the area of this larger peak or the initial peak from 0 to its maximum. So this length from the length of this peak, half of the peak is L1 and half is L2, and then L2 divided by L1 is basically springiness. So it is basically the ratio of time which is measured from the start of the second and the first cycle of the pressing to reach maximum deformation during each cycle. And then the chewiness is there. So chewiness is gumminess into L2 by L1. So gumminess into springiness is the chewiness. And what is gumminess? Gumminess is basically the multiplication of hardness and cohesiveness. So hardness, which is this maximum force, into the cohesiveness. Cohesiveness is A2 divided by A1, which is this area of this small peak, half area, and divide by the large peak, half area. It is a cohesiveness. So basically when, and this whole texture profile is basically when someone is eating, is for the purpose like someone is eating any fruit. So when it is taking the first bite, how it will behave, with the force with respect to time. So it will behave like this. Then when we are taking the second bite, so how it will behave? It will have the smaller peak like this. So this is all this includes in the textural property of any food product. So this is basically the textural analyzer. So from this is like the probe, and this is the fruit. So fruit is placed at the bottom, and the probe is coming and putting the pressure. And when the probe is coming and putting the pressure, this kind of graph will generate with force with respect to time. And it will tell when any human being is eating any fruit or any food product, how it will behave, the food product, how it will behave when it will have the human being is having first bite and the second bite. All these parameters will indicate like this. And this is basically the penetrometer, which is basically used to measure the fruit firmness. So this is basically the penetrometer and the texture analyzer. So texture analyzer is this one. This is the textural analyzer, this tool. And penetrometer is this one. So from texture analyzer only we get this kind of graph, and we get all these parameters like adhesiveness, cohesiveness, springiness, gumminess, and hardness. In penetrometer, we only get like with force with respect to time. So how much is the peak? Like this, it will come. So this is peak forces, basically firmness in the penetrometer. So the firmness of the fruit. So firmness is basically a sensible textural property, and it is determined by basically the mechanical and structural characteristics of fruit. So how much is the force we are applying? So there is an mechanical property involved, and the texture or the structure of the fruit, how it is resisting that force. So that is a structural property included. So it is basically the resistance of the fruit tissues to the deformation or penetration. So when the probe is penetrating any fruit, how much the structure of the fruit is deforming, or resistance, how much it is creating under any applied force, is basically used to determine the firmness, and it is basically a good indicator of how much the fruit is mature or ripen. So when the fruit is basically fresh or intact, so the firmness is more. But with the storage time or the spoilage, the firmness will be low. So assertion which is regarding texture, which is basically, especially the firmness, is basically important index in the maturity, and it reflects the consumer acceptability and post-harvest handling and the quality and the shelf life of food product, which is correct. And the reason, which is the penetrometer and texture analyzers, they are using to measure the firmness basically of the fruit, not for the morphology. For morphology, there are different other equipments like scales and the sizing machines and the tapes are there, which are going to measure the structure or the morphology of the fruit. So the reason is not correct. So for measuring the morphology, like the physical parameters of the fruits and vegetables like the size, weight, and the curvature, there are different instruments like scales, sizing machines, tape measures. So it will going to measure the morphology of the fruit. Suppose like this is basically a vernier caliper, which is measuring this part, this scale of the fruit. And this is basically band loop caliper, so which is measuring the round, how much is the diameter or round area is there. And then this is basically a sizing ring, of which size, like we say small size of fruit, large size of fruit. So by this we measure this size. From sizing ring we measure this, and this is fruit dendrometer. Also, there, like if we are having this fruit and this is basically the length, this is basically the width. Like this, we can measure of any kind in any fruit or vegetable. This is a morphology basically. Okay, so next question is regarding soluble solid content is used as an indicator of fruit maturity and optimal harvest time. And reason is acidity level determines the sugar content and sweetness of the fruit. So, which is basically this total soluble solid and acidity, it basically comes in the nutritional attributes in the quality characteristics of the fruits. So, it is basically the internal attribute of any fruits or the vegetable. Anyone who would like to answer this question? A, Satyam? Okay, let's see. Answer C is correct, that here assertion is true, but the reason is false. Let's see why. So basically this soluble solids, it is basically measured with the refractometer. Like this is the refractometer. Here we put the fruit juice drop and we see from here we see like this scale how much is the degree Brix of the total soluble solids. So it basically indicates the sugar content in any fruit. So it helps to understand how much is the mature is the fruit. So if more sweet sugar content is there, that means the fruit is under ripening and it's more matured. Whereas if the maturity level is less, so the fruit is more fresh, then the soluble solid or the sugar content is low. So this is basically indicator of fruit quality and optimal harvest time, which is true. Whereas like this, if we see one example, so when the total soluble solids in the papaya, mango, banana, wax apple, and tomato are measured, so if we see this is first one is for papaya. So this is increasing when the storage time is increasing. Also, if we see banana, which is C, so yellow color. So all are increasing with, so when we can say when the soluble solid content are increasing, when the ripening state is increasing. So from unripened to over ripened when the fruit is go, so the total soluble solid increases. However, the reason is incorrect because the acidity level, it reflects basically the microbial susceptibility or the prevention potential of the fruit, because this factor directly affects the ease with which the external agents or the microorganisms can enter in the fruit. Not, it will not tell the level of the sugar or the sweetness. Basically, this is the pH probe, which is used for measuring the acidity of the fruit juice. And if the fruit juice is more acidic, then there is a less possibility of chances of attacking of any microorganisms. So pH basically it affects the microorganism attacking power on any fruit product. Suppose this is the water. So water is having 7, which is neutral pH. But if we go like the milk, it is having 6 pH. Then coffee is more acidic. Then tomato is more acidic, and the lemon juice and the apple juice, they are more acidic towards acidic products. And the this egg is around pH 8, baking soda, and like this, the here on the right side, the pH is increasing. So we can see that in the apple pH is basically around 3.3 to 3.9 due to presence of malic acid, and tomato, the pH is around 4.3 to 4.9 because of the presence of oxalic acid, and pH of milk is around 6.7 to 6.9, which is near to the neutral, so due to the lactic acid. So when the fruit or any uh, food product is near neutral, then there is a more chance of attack, or like there is a more probability or more chances of attacking of microorganism and spoiling it. But if a product is more acidic than like the apple juice or the lemon juice, then microorganisms will cannot easily attack that food product and spoil that food product. So the pH basically affects microbial energy metabolism, involving the buildup of the gradient of H plus ions across the membrane. So it affects the microbial enzyme activity also, and the cellular macromolecules. So overall, it affects the pH affects basically the growth of the microorganism in the food product. So in the table, we can see there are different vegetables and fruits here. So they have different pH, and we can see some are more acidic and some are near to neutral. So the microorganisms can attack more on the products which are near neutral or less acidic. So here acidity level, it is not telling about the sugar or the sweetness level of the fruit. It is in regards with the H plus ion concentration, and also how much is the microorganisms can attack or not attack on that particular food product. Then, which of the following statements regarding climate requirements of spices are correct? Tropical spices require high temperature and humidity but are sensitive to cold. Subtropical spices need low temperatures for vegetative growth and higher temperatures for reproductive stage. Third is temperature spices. Temperate spices can withstand hot weather and high humidity better than tropical spices. And then fourth is ginger and turmeric can grow in both tropical and subtropical climate. So it is now we are discussing about the spices. So spices basically they can be classified based on different bases. Like if the spices they are taken from different parts of the plants, like from the seeds or the leaves or the roots or the barks, it can be classified on the separate basis. And based on the economic importance, like major and minor spices, and then botanical classes, like based on the genus and which family. Hello. Hello. Am I audible?
Yes, ma'am.
Okay, thank you.
You're welcome.
Yeah, so we were discussing that the spices they can be classified based on the their botanical classes, like which genus or which family they belong, and also based on the climate requirements, whether they can be the good spices crop can be grown in the tropical regions with a basically high temperature and humidity, or they can be grown in low temperature. So based on that also spices can be classified based on their origin and flavor, like if they are having the pungent smell, or they are having the phenolic or aromatic smell, or they are giving the color to the food product. So based on that, Also, there is a classification, and also based on their life cycle of growth, like whether they are growing in the like in one season or 2 season or in more seasons. So they can be classified like annual, biennial, and perennial. So here we are talking basically the classification based on climate requirements. So uh, about the tropical climate, tropical spices, subtropical, temperate spices we are discussing here in this question. Okay, so we got A as the answer, which is 1, 2, and 4 here, which is correct actually. So these spices, which are the tropical spices, they can be grown in high temperature and high humidity, but not in the cold temperature. There is a subtropical, they can be grown in the low temperature, and for their reproductive stages, they need higher temperature. And also the ginger and the turmeric, they can grow in both the tropical and subtropical climates. So based on the climate, this classification. So this tropical spices, they can include basically ginger, turmeric, black pepper, cinnamon, kokum, and all these cloves and the cardamoms. All these are basically this tropical spices, and they can basically grow in heat and humidity. And when there is a low temperature, they cannot grow. In the subtropical spices, they are basically they require basically low temperature to grow for their vegetative or early growth stages. But at when they are undergoing the reproductive stage, they need higher temperature. So it includes basically cumin, fennel, fenugreek, coriander, etc. And in temperate, they need particularly less than 5 degrees Celsius and frosty weather. But in hot temperature, the crop will get damaged, like saffron, thymes, all these things. And if we talk about the ginger and turmeric, they are basically under both the tropical and subtropical category. But the temperate spices, they can be damaged under the hot weather. So here it is saying that the temperate spices, they can withstand hot weathers, which is wrong. Okay, guys, let's move to this question, which is phenolic compounds in spices contribute to their antioxidant property. And reason is phenolic compounds have a linear correlation with lipid content in spices. Anyone who would like to answer this question? Poonam is saying C, which is A is true and R is false. Poonam, you are correct that the phenolic compounds basically they provide antioxidant effects in the spices, and they are basically related with the antioxidant activity and not the lipid content. So reason is false. So these spices basically in these spices we can extract these phenolic compounds basically using the polar solvent extraction methods. And after that, like we can put some polar solvent in which these spices can be put as a powder form, so that the phenolic compounds can be removed. After that, there will be stirring and centrifugation, so free polyphenols we can get. And then from the residue, it can undergo the alkali extraction method or the aqueous alkali, or this is the alkali and this is the acid. So we can use either NaOH, KOH, and also we can use in the acid like H2SO4 or HCl. We can maintain some pH, and we can remove the aqueous layer. Then we can extract with hexane, and after that ethyl acetate, and we can get the bound phenolic compounds. So bound phenolic compounds are basically the phenolic compounds which are bound to the cell wall, like cellulose, which can bind to cellulose, hemicellulose, or lignin. So these are the polyphenolic compounds. They are bound to this cell wall material. We can get from this spices like this, we can get the polyphenols. And in the spices, we can have different phenolic compounds, and they can be used for different important activities like pharmacological actions. So they, like the clove, it is having the active compound eugenol. So it can be used basically to reduce the inflammation, and it can have the antioxidant activity, antiviral activity, antimicrobial, anti-inflammatory activity. So all these spices which we use in our home, they are having some active compounds in them, which is very good for our health. So in the coriander, suppose if we are seeing, so there are two active compounds like cetosterol and stigmasterol. So in saffron, there are safranal. So these are the bioactive important compounds, and their structure is given in this here. So they can be used for various important functions in our body, like in mustard, camphorol is there. In ginger, like catechin is there, gallic acid, gingerol is there. Then in cinnamon, hydrocinamic acids are there. In turmeric, curcumin is there. So these are all have very important functions in our body. And these polyphenols, as we discussed, that they have the antioxidant activity. So uh, basically these polyphenols, they will donate H plus atom, H atom, to the free radicals, which is, suppose it is having free radical. So it will connect, bound, and stabilize these free radicals, and that's why it will help to the suppression of basically the mitochondrial ROS generation, and also in like different health effects it will show, because this polyphenol, they has the ability to donate H atom. And also because these polyphenols, they are basically help to upregulate or to downregulate certain enzymes or certain genes, so that way also it is very helpful for different like functions, or to protect the cells basically from the oxidative stress, and also from the cell death. Okay, let's discuss about fumigation. So which statement is correct regarding the disinfection of spices? So one is regarding phosphine. So phosphine is widely used as a fumigant and has minimal impact on spice quality. Second is ethylene oxide fumigation is widely used due to its effectiveness and safety. Then third is methyl bromide is suitable for vacuum fumigation and spice powders. So basically spices, in spices, we can have different insects attack. So for infestation, we use different methods like fumigation, in which we use chemicals uh, in the gaseous state, which will going to control these insects and the pests. And then there are the irradiation methods like in coriander, cumin, turmeric, and chilies, like the gamma radiation of around 10 kilogray to it is applied, so that the shelf life of this spices can be increased to 6 months. Then heat treatment can also be applied, like 70 degrees Celsius for 15 minutes. This can be These can basically reduce the microbial load so that the shelf life of the spices can be increased. So this method is basically this fumigation method. All these methods are the fumigation method. So in fumigation method, what we are doing, we are using some chemicals in the gaseous state so that the pesticides can be removed, pests can be controlled. So these all are the chemicals. So that's why we are talking about whether these chemical can be used and can be act as a food safe material or not. So Poonam is saying see here only one, which is phosphine is widely used as a fumigant. So Poonam, you are correct that phosphine basically it is used for the disinfection of spices and spices powders, and it will not affect any quality, and it is used around in the dosage of 2 to 4 aluminum phosphide tablets per ton of the commodity, and for not less than 5 days has been used against spices and spice products. Whereas this methyl bromide is basically used, it is basically effective in the fumigation of the spices, but not identified to cause, but has been identified to cause serious ozone depletion. So this methyl bromide, it can be used as a fumigating spices, but it is having negative environmental impact because it is depleting the ozone layer. So it is having ozone depleting potential ODP, which is around 0.7. So generally we will not use this methyl bromide. So it is generally used at 24 to 48 gram per cubic meters with an exposure period of around 24 to 48 hours under normal atmospheric conditions. The gas is relatively less effective than ethylene oxides against the microbes. It is particularly suitable for vacuum fumigation for processed and packaged foods. So it is basically using for the fumigation this methyl bromide for vacuum fumigation, but mostly not direct application, but in the form of the packaged food products or packaged spices. So this next is the ethylene oxide. It is basically used for the sterilization process, but it is having carcinogenic materials like it forms chlorohydrin and bromohydrin residues, which is going to have the negative impacts on human health. So it is discontinued for its usage. Then fumigation of cloves, basically it can be done using ethylene oxides at a dosage of 550, 750, 1000 grams per cubic meters for 6 hours at 20 to 25 degrees Celsius, and it these fumigation methods, they also like decrease the volatile oil content. So it decreased from 1.7 to 2.2. So when we are using these fumigants repeatedly, they will going to even decrease the volatile compounds in the essential oils and lead to the discoloration. So they'll have both the negative impact on the spices and the uh, environment also. So usually this methyl bromide is not used because of the negative environmental impact, and ethylene oxide has negative impact on human health, so it is also not used. Only this phosphine is basically used. Next is the question on coffee. So a specialty coffee company is designing two new product lines. One is for the premium customers and another is for the mass customers. So the premium customers, they basically prefer mild aromatic brew coffee, whereas the mass market prefers strong budget-friendly coffee. So we have two coffee Arabica and Robusta. So which uh, coffee should be used for which purpose? For premium customers and for mass production methods or mass customers. Anyone who would like to answer this question? Okay, so Poonam is saying C, that Arabica we can use for premium customers and Robusta for mass market line. So she's correct. So there are the three varieties of coffee: Arabica, Robusta, and Librecia, but mostly Arabica and Robusta is basically used. So the Arabica is basically for mild and aromatic, flavorful brew, and it is basically used for the premium products, and it is basically delicate, grown and high at high altitude and has lower yield. Whereas Robusta, it is basically having strong odor or strong flavor, and it is having good yield also, and it is disease resistant, so it can be used for the mass market production. So when we want milder or more aromatic or flavorful coffee, we can go for Arabica. Whereas for mass, which is having thick and strong flavor, we can go for Robusta. In both the coffees, like the coffee Arabica and the coffee Robusta, the caffeine content is having different amounts. Like in Arabica, around 0.9 to 1.3 gram per 100 gram is the caffeine amount, whereas in Robusta it is more, which is 1.5 to 2.5. And in the coffee production, in the coffee is basically produced from the coffee cherries. So the coffee cherries is basically it is basically uh, taken and it is converted into green coffee beans. Basic drying, hulling is done and converted into green coffee beans. After the production of the green coffee beans, it is basically roasted, and after roasting, it is grinded and can be used for the brewing purpose. When we are producing the coffee, the fermentation process sometimes we do, and when we are doing the fermentation, this from the pulped coffee beans, when we are doing the fermentation process, this is very important for the generation of the flavor, this fermentation process. So it should be done carefully. And when we are just drying coffee beans, it should be dried in 6 stages. Like first, kiln drying should be done, which is having moisture content around 55 to 45. Then white stage drying, which is having 44 to 33 moisture content. Then soft black stage, in which moisture content is reduced to 32 to 22. Then medium black stage, in which moisture content is further decreased to 21 to 16%. Then hard black stage, in which the moisture content is reduced to 15 to 12%. And after that, full drying stage, which is in the coffee, the full dried stage is 11 to 10% moisture content when it is having. So we are decreasing moisture content slowly, so the flavor, the characteristic flavor can be maintained properly. And in the coffee, basically, the roasting process is very important, which is done at very high temperature, like 210 to 240. And the coffee is basically having the brown color and distinct aroma, which is because of the compound formation of malodins. So these malodins basically are formed, also the caffeine and other compounds like furans and pyrazines are formed. So these are basically due to the reaction of this Maillard reaction and caramelization. So there is a characteristic brown color and also the the characteristic flavor and the aroma of the coffee. So the roasting process is very important when it comes to the coffee. So here answer is C, which is that Arabica can be used for premium and Robusta is used for mass market line. Okay, so next question is about that daily wellness beverages some professional is making. So that the urban population, it basically experiences high stress, sedentary lives and irregular sleep patterns. So this the product which the person is making, it should support cognitive function and protects against chronic diseases, diabetes and liver disorders, and also improve the energy levels. So which ingredients options that team should see in the coffee, and why would coffee be suitable inclusion in the wellness beverages? So in wellness beverages, we can include coffee, but why? Poonam is saying D, Satyam D. Okay. So coffee provides energy and supports memory, liver protection, and disease prevention. So both guys are correct. So basically, coffee has some bioactive compounds in it, which will going to enhance the energy and improve the memory, and also protect the liver. And it reduces the diseases risks like diabetes, heart diseases, and cancer. And that's why it is used in the wellness products, which has uh, basically the aim of having health conscious and high performance individuals. So basically this coffee, it is having, as we discussed, different bioactive compounds. So these bioactive compounds shows two properties, antioxidant and anti-inflammatory, which is very helpful for the neuroprotective actions and also for protecting the heart health and then liver protection and also from the bone density reduction. So it will protect from all these because it is having different bioactive compounds. So like for anti-cardiovascular activity, suppose, so it for good health, good heart health. So the coffee is having these different bioactive compounds. So here CGA is basically chlorogenic acid. Chlorogenic acid. Chlorogenic acid. So this coffee is having chlorogenic acid, then caffeine, then melanoids, then trigonel, tri, trigonelines. So all these compounds, they are basically good for heart health. And caffeine and this chlorogenic acids and this trigonelines, they are basically good for diabetes. It is helpful to prevent the diabetes. And even coffee is having this caffeine. So this caffeine is very important if someone is going from nervous related problems like Parkinson disease, or it is also antidepressant. So if someone is very depressed, it can have some caffeine. So for the time being, it will be helpful to improve the brain health. Also for antibacterial functions, all these active ingredients in the coffee are there. And for anti-cancerous activity also, it is having, it is showing anti-cancerous activity because it is having caffeine and then also chlorogenic acids and then C and K, which is cafestol and kagol, so which is very important compound for anti-cancer properties. Which tea is partially oxidized during manufacture? So green tea, white tea, oolong tea, and black tea. Anyone who would like to answer this question? Oolong tea, Poonam. Anyone else has a different answer? Is correct. Oolong tea, basically oolong tea is semi-fermented one. So white tea is basically this one, and then green tea is the unfermented one, which is not fermented. So in white tea, the tea leaves will be directly weathered, dried, and it's white tea. And in green tea, weathering is done and pan frying is done, then rolling, then drying, and then green tea we get, which is unfermented one. So the fermentation process is not there in the green tea. Whereas in oolong tea, the fermentation process is there, but it is semi-fermented. Whereas in the black tea, it is the fermented one. So after withering, it is basically rolled, and after rolling, it is fermented. It is not dried first, like in the green tea. It is first fermented and then dried, and then black tea we get. We can see that in the tea, the polyphenol content is very high, and it is having around 3.5% of the caffeine. And if we differentiate between black tea and the oolong tea, so the fermentation process is shorter here, whereas in the black tea, the fermentation is a full fermentation process. So here in the green tea, there is no oxidation of the polyphenol compounds, whereas in the oolong tea, the partially oxidation is there, and in the black tea, the fully oxidation process is there. So here, partially oxidized one is the oolong tea. So guys, we covered today basically about the horticulture situation. We covered about we discussed about cashew and its production, and we discussed also about uh, vitamins, like the nutrition profile of the vitamin C in different fruits. And then we discussed about the respiration in detail, about its methodology, like how is it measured, and what is a respiration, what is its types, and what is the RQ value. And then we discussed about the transpiration process also, and we solved two numericals on each one on the respiration, and one is on the transpiration process. And then we discussed about the spices and its infestation method, which is a fumigation method. And we discussed about the antioxidants in the spices, and we discussed about coffee, tea also in detail about their classes and all. And in the next week, we'll be discussing about post-harvest losses, and then post-harvest operations and handling and transportation, supply chain management and storage, and Q&A and Q&C. So this will be basically my YouTube channel. This is my YouTube channel. So after this lecture, I'll be uploading the recorded video of this week 1 on this YouTube channel link. This is my YouTube channel. So you can visit this to watch the recorded lecture of every week. And this is a Google Drive link where I'll be uploading the presentation and of every week. So you can visit, and this is my email ID. You can go through my email ID for any question if you have any doubt. But I'll ask you, I'll prefer this group for Q&A, So you can join this Q&A group, which is basically if you have this window of the course portal, so you can go to the course of this course, and in go to the course, this is a tab which is Q&A. So when you go in this tab, you'll find the group where you can access like all, you can put their questions there, and any of the TA can answer that question. If you have, like, if you are reading something and in the middle of the week you get some doubt, you can post in this Q&A. So thank you so much, guys, for joining this class. Next class will be on next Sunday, 4 to 6, and thank you so much for connecting. And this is basically the end of the session, and you can leave the meeting if you don't have any doubt. And if you want to ask me something, you can either put me on right now, you can put on the chat, and also you can talk me, you can unmute yourself and talk to me. I'll be happy to answer any doubt. I'm so sorry for the today's internet problem. I'll check beforehand. I am in the next session, from the next session onwards, I'll be checking. So if you have any doubt, please, you can ask. And if you have no doubts, you can leave the meeting and you can join the next lecture on the next Sunday, 4 to 6. Also, you want to give me any feedback, maybe regarding how I was teaching. So if you are not comfortable and you want to make some changes, you please give me some feedback regarding it so that I can change my teaching style based on your feedback. Anything you would like to discuss, anyone? Assignment. Assignment means the quizzes which is there on the portal. Quiz 1, quiz 2, like that. So the first quiz includes around 10 questions, and its deadline is 5th of August. So kindly submit on time your first assignment or first quiz. You should like, without fail, you should complete your quizzes on time. And this I hope these sessions will going to help you for solving your quizzes. Yashvi, is it clear? Or you want further further clarification on the same? How to give the quiz map. So when you have this course, let me show you. My screen is sharing in sharing form, right? Okay, let me show you. So this is basically with Yashvi. Okay, so my screen. So suppose this is the course, right? So you can go and join the course. Yeah, so this is the course, and this is week 1. So on the left side, you can see this is the week 1 lectures, 1, 2, 3, 4, 5. After week 1, there is quiz and week 1 assignment. So you can go here. This is the on 5th of August. Before that, you should submit. So there are 10 questions. So it is showing above that assignment is not submitted. So this all these assignments for each week, like for 12 weeks, 12 assignments will be there like this, and you need to submit all these assignments for the evaluation purpose, so they will be assessed. And this is week one question. So here, this is like this. If you are clicking on option A, so it will be A, here B, C, and D. Like that, you should do all for the 10 questions. And then you can do submit answers, and your submission will be done. And for this week, it is like this submissions will be done like this. Yashvi, is it clear?
Yes, ma'am.
So all these are for the evaluation or the assessment perspective. So you should do all these things on time. After that, once the deadline is crossed, you will not be able to do. anyone has any other doubt, I'm stopping the recording and I can give you this recording after like maybe 2 days. By the end of today, I will upload this on my YouTube channel. You can see this recorded lecture. And others, if you have doubt, please stay. Otherwise, you can leave the meeting.